Imagine you're sending a letter to a friend. You need a way to write it, pack it up, send it, and make sure it gets to the right person. That's basically what computer networking protocols do. They handle everything needed to send and receive data between computers. Let's break it down so it's easy to follow. When you open a website, your computer first uses HTTP or HTTPS. Think of this as the language for asking for and sending web pages. HTTP says, "Hey, I need this web page," and the server replies with the information. HTTPS is the same thing, but it adds a layer of security by encrypting the message, like putting your letter in a tamper-proof envelope so no one can read it along the way. Now that your request is written, it needs to be packed up and sent. This is where TCP comes in. TCP is like the organizer. It chops the message into smaller pieces called packets, numbers them so they stay in order, and makes sure they're delivered. If a packet gets lost, TCP says, "Hey, resend that part." It's reliable and thorough. On the other hand, UDP skips all this extra work. It just sends the packets quickly without checking for errors. This is great for things like video streaming, where a tiny missing piece doesn't ruin the whole video. Once your message is in packets, IP assigns each one a to and from address. This is like writing your friend's address and your return address on the envelope. Routers then read these addresses to figure out where to send each packet next, guiding them across the internet to the right destination. But there's more happening behind the scenes. DNS, for example, is like a phone book for the internet. When you type in a website name, DNS translates it into the IP address the computer actually needs to find the server. Without DNS, you'd have to memorize strings of numbers like 192.168.1.1 instead of simple names like google.com. Other protocols help handle specific tasks. FTP is used for transferring files between computers, like moving documents from one server to another. SMTP sends emails, while IMAP and POPI3 are used to receive them. SMTP is the postman taking the mail to the mailbox, while IMAP or POPI3 is you opening the mailbox to retrieve it. There's also ARP, which works within a network to match IP addresses to specific devices using their MAC address. Think of it as figuring out exactly where someone is in a big house based on their room number. And ICMP is the error-checking protocol. If a packet can't get delivered, ICMP sends back a message like, "Sorry, your package couldn't be delivered." All of this happens in seconds or even milliseconds. First, your computer writes the request using HTTP. TCP packs it up into packets. IP adds the addresses, and then it's sent through cables, routers, and networks. When it reaches the destination, everything is unpacked and reassembled in the right order, so your computer can read it and display the web page. These protocols work together like a perfectly choreographed dance, making sure everything you send or receive on the internet gets to where it needs to go. Next time you send a message or browse online, just know there's a lot happening behind the scenes to make it all work seamlessly. If you've got questions about any of this, drop them in the comments, and don't forget to subscribe for more simple tech breakdowns.